In this exercise, we will practice data selections on both pandas series and pandas data frame objects. We're going to read the CSV file. The CSV file is basically a dataset coming from the World Bank and contains the population of countries across the world over multiple years. We're going to read this data now, and you can see here that if you take a look at this data, we have a data frame, and this data frame has 5 rows. Well, the data frame doesn't have 5 rows. The head of the data frame has 5 rows because we pulled the first 5 rows, but the data frame has 63 columns. And those columns are the country code, indicator name, indicator code, and then years from 1960 to 2018. We also have a junk row here, so that probably has to do with how the data is formatted in the file itself. We're going to look more about data cleaning in the next lectures. Now, what I want to really emphasize in here is that this is not a column. This is basically the index. And we can actually probe into the index. If I do data.index, basically tell me that the index is basically country names. Similarly, if I do data.columns, basically going to list the columns for me. So those attributes are very important, and very often if we are exploring a data frame, a data set which we're not very familiar with, it really makes a lot of sense to take a look at both the index and the columns as well as the head of the frame. Another very useful exploratory step that we need to do is to basically look at what's inside. Now, if we take a look here, you can basically figure out what the country code, country name, indicator code are all string values, and those are numerical values. The attribute dtypes, which stands for data types, basically give me this information for all of the columns. It basically tells me, what columns are object or strings and what columns are numerical. In this case, all of them are float, but they can be integers or other kind of numerical data types. So this exercise has 2 sets of questions. The first set of questions is asking us to do indexing and selection on a series. And the second set of questions is asking us to do indexing and selection on a data frame. So for the first set of questions, we're not looking at the whole data frame. We're only looking at a series. So I pulled the column 2018 from my data frame and I stored it in a series called population 2018. If I do head of that series, I see that it has population values for the countries, right? The countries are the index. Once again, this is a series. If you are in doubt, you can use the Python function type, and this will tell you that population 2018 is a pandas series. Data is a data frame, right? So right now we're only concerned about series, not about the data frame. Okay, let's take a look at population 2018. What's the population of the United States? Now, in this question, I'm giving you the index, and I want the value associated with this index. So that's basically a simple indexing operation. Basically, I can do population 2018, square bracket, the value of the index, which is United States, and I get the value associated with this index. Once again, if you are in doubt, the series, you shouldn't be in doubt a lot because there's only one default decision that pandas is making, which is whether to use the explicit or the implicit index. And because you're providing a value here, which is a string, there shouldn't be any confusion here. The confusion only occurs if your explicit index is also numerical. However, if you want to be very verbatim about what you're doing, you can tell pandas that, look, I want to use the explicit index and I want the value associated with the United States. Increase this number by 1. That's basically reading this and writing it again. So we can do that here. We can do population United States is equal to population United States plus 1. That's simply to say that you can also write values back to the series. We often don't do that because we often don't manipulate the values in the series in a notebook, one value by one. Now this warning we got is basically telling us we are changing the series, but you know this series is coming from a data frame, so most likely the data in the data frame has changed. This is a warning, and it's a very useful warning because don't forget the data exists in the data frame. So even if you're manipulating a series, you're touching the data in the data frame, which you may want or you may not want to do this. Okay, the next question is asking us to select the population values of multiple countries: United States, Canada, and Mexico. What kind of selection operation is this? Indexing, slicing, or fancy indexing, or masking? Well, the answer is it's fancy indexing, because I'm selecting multiple values. So I'm going to access population 2018 one more time. Instead of providing one value, I want to provide a list of values. And the list of values here are United States, Canada, and Mexico. That basically will give me a series, right? Because I selected multiple values, I don't get a number, I get a series of numbers, right? And the series has the index being the country, and I obviously get the values associated with the countries I asked for. Once again, if you are in doubt, if you can do .lock here, because you're using the explicit index. All right, select the population values of the first 5 countries in the series. Now, in the past, we used the function head, which we still have access to. We can do population 2018.head. By default, it's head 5. It can be explicit here, and that will give me the first 5 entries. But let's use the indexing operator, the square bracket, to do the same. What kind of selection operation is this? Indexing, slicing, fancy indexing, or masking? The answer is it's slicing. Now the second question you need to ask yourself, am I slicing on the implicit or explicit index? And the answer here is the implicit index, because I want to have the first 5 countries and I have no idea what those countries are, right? So what I'm going to do here, I'm going to do population 2018 iLock for implicit index 0 to 5. Now don't forget that the end is exclusive, and hence I'm getting 0, 1, 2, 3, and 4, which are 5 values. The 0 can also be omitted. Okay. What if I do something like this? Would that work or not? It actually works. And the reason it works is that Pandas figures out that, well, the explicit index is not numerical anyhow, right? When you provide numbers, it's going to use the implicit index by default. So it's making that default decision, which makes sense. Once again, if you're not sure, use iLock. I mean, obviously you cannot do lock here because the explicit index is not numerical, and you will get a type error here because those numbers don't exist on the explicit index. Select the population values of the first 5 countries in the series. Well, that's we already answered. Select the population values of the last 5 countries in the series. We have seen the tail function before, so we can use it, but we can also use indexing as well. What's the slice here? Last 5 countries should go from -5 to the end. And those are the last 5 countries. If you don't want Pandas to make that decision for you, you can do iLock to specifically say that you want to use the implicit index. Finally, let's select the population values that are larger than 1 billion. What kind of operation is this? Indexing, slicing, fancy indexing, or masking? It's actually masking. So we need to create our mask And our mask should be population 2018 greater than 1 billion. So 1 billion is, I need 9 zeros, or I can do 1E9, which will basically give me 1 and 9 zeros. And you can see that it's a Boolean series, and obviously it's false for most of the countries here. What I'm going to do now, I'm going to use my mask to index my data frame, my series here, and that will give me these countries that have more than 1 billion in population. Now what you notice in here is that there are some values which are not countries. This dataset contains countries, populations, as well as geographic regions, such as continents or some geographic regions. This is something inherent in the dataset, and this is something we will work on and improve in a very future exercise. We are only selecting the countries alone rather than the aggregate. For this exercise, we're going to contend that not all of these are countries, but obviously we have the 2 countries that have more than 1 billion people so far, which are China and India. Now next we're going to do indexing and selection on the data frame itself. So the data frame name is data. Select data of years 2017 and 2018. Now we've already selected data of 2018, and that gave us a series. Now I want to select both 2017 and 2018. Indeed, it's a fancy indexing operation. Instead of providing one value, I need to provide 2. I want to provide 2017 and 2018. And I don't get a series anymore because I've selected 2 columns. So what I get a data frame. Once again, many often I want to assign this to a variable. I don't want to just dump it on the notebook. But for the sake of this exercise, we're just focusing on the selection operation. So I'm not going to assign it to a variable for now. Now you ask yourself, okay, what are the default decisions that Pandas made? Well, there are 2 default decisions that Pandas made. One of them is whether this selection is operating on the row axis and the column axis. And the second one, whether it's using the implicit or the explicit index. Now here, because I'm indexing or fancy indexing, it's basically going to operate on the column axis. Had I been slicing, it would have been worked on the row axis. Meaning, you may think that you can do something like this. 2017 to 2018, but you'll get an error. That may be a very surprising error, but I'll get back to this one very short. And that's because the Pandas is selecting the axis based on the operation. Let's now be more specific about that. I don't want to live in doubt for now, so I'm going to say specifically to Pandas, look, I want to use the explicit index, and look, I want to have all of the rows, and look, I only need to have 2 columns, which is 2017 and 2018. That will be basically the same result, but I specified exactly what I want so that I don't live in kind of fear of Pandas doing the right decision for me. Once again, once you do these operations many times, you will come to internalize them, and I hope you will get to appreciate the default decisions that Pandas make. Okay, so let's go back to the slicing operation. Now, here, I can also do slicing. I can say, well, give me a slice from 2017 to 2018. And this time, I'm not gonna get an error like what I got above, simply because Pandas knows that now you're slicing on the column axis. Because if you don't provide lock, by default, it's going to slice on the row axis. Once again, multiple ways to get to the same answer. Okay, now we want to select entries of countries, United States, Canada, and Mexico. So basically, I want to select rows rather than columns. So if you do something like data United States, Canada here, and Mexico, that's going to create an error because by default, Pandas is going to assume that those are columns, right? So now the default choice is incorrect anymore. So then I want to be specific, and I can say that I want United States, Canada, and Mexico, but I want to do lock here, right? That's the explicit index. That's the fancy indexing operation. Give me these 3 rows, and I get a data frame that has these 3 rows and all of the columns. Obviously, I could have said all columns. That's not needed. It will be the default, but I can do it to be more specific. Next, I'm selecting on both the row axis and the column axis. So I want the 3 countries only in years 2018, 17, and 18. So then I basically need this thing here. And now I have 2 options. Either I provide a slice here or a fancy index. So let's do a slice 2017 to 2018. That's the 3 countries in these years. Or I can provide this as a fancy index. Just a list 2017 and 2018. I get exactly the same thing, right? So again, now you notice the structure here. Lock, 2 coordinates, rows, columns. What do I need on the coordinates? Basically fancy indexing, or fancy indexing and slicing give me these values. Next, it's asking us to report select data of years 2000 to 2018. So we can do fancy indexing, but that's a lot, right? 2000 to 2018. It's much easier to do slicing. So, and I am slicing on the columns axis, so I have no other way to do it but to use lock, because slicing by default is interpreted to be on the row axis. So I need to have select all of the columns, and I'm going to have a slice from 2000 to 2018. Now, if you ask yourself why this is a string rather than being a numerical value, which is a good question to ask, it has to do with how these were represented in the column axis. So take a look at the columns axis. You can see that those values, although those are numbers, were stored as string. Hence, I'm putting them in quotes. Okay, so that's my slice, and that's the slice of the data. All of the rows, columns from 2000 to 2018. Okay, now we are selecting 2 countries, Aruba. Well, we're selecting actually a slice of countries, Aruba to Azerbaijan. Once again, in this operation is better done in slicing, because I don't even know what are the countries in between Aruba and Azerbaijan in this case. So that's basically the same here, except that it's flipped. I want all of the columns, but I want only countries from Aruba here to Azerbaijan. You most likely committed a typo here, Aruba, and that gives me the slice. Next, I'm going to select countries that have more than 1 billion people in year 2000. Okay, so that's interesting. How do we get to answer this question? Well, first, let's take a look at this criteria. More than 1 billion people in 2000. That means we need to compare population in year 2000 with the number 1 billion. So what I'm going to do here, I'm going to take data 2000, which basically gives me a series with population of countries in 2000, and I'm going to compare it to the value 1 billion here. What do I get? I get a mask. Now I can use my mask again to index my data frame. So I can do data, square bracket, my mask. By default, when you do a mask, Pandas is going to use the row axis. Now, if you don't want to be in doubt, you can actually be more specific, and you can say, okay, that's a lot, lock, and then the mask. That's basically the same thing. Those are all of the entries of all of the countries that had a population more than 1 billion in year 2000. Once again, we don't have only countries, we have geographic region. Next, we're asked to select the first 5 rows. Again, head is basically your default go-to function here, but we can also use slicing here. Now, we want to slice on the implicit index. Because there is an explicit index here, it's possible to say, 0 to 5. And pandas will understand that now you want to use the implicit index. If you don't want to be at the mercy of the default decision, you can do ilock here, and that will basically give you the first 5 rows. Next, it's asking us to select the first 5 rows in the first 5 column. That's basically an extension of this one. You can do ilock beginning to 5 and also beginning to 5 on both the row axis and the column axis. And here we've got only 5 columns and 5 rows from the original data frame. This concludes these operations, and once again, there are multiple ways to get the same answer, the right answer in each one of them. It basically rests on knowing the different operations, the data structure, and the fact that we have 2 indices on each axis, implicit and explicit. In the future, we will get back to these topics and we will be using indexing and selection extensively.